Hi everyone. Today we're going to learn on solving simultaneous equation. In this video, I'm going to share some examples on linear equation, solving linear equation with three unknowns, and also we will look at examples on simultaneous equation, which involve the linear equations and non-linear equations. And a non-linear equation, it might be quadratic, or it might be an equation involving the surd. All right. So let's look at the first example. I have a one simultaneous equations, solving this simultaneous equation, which the first equation is the linear equation, and the second one is the a circle. Yeah, this is actually a circle. So to solve this equation, we're going to name the first equation. Before we name this equation, I'm going to write one of the unknown. For my convenience, I will let the x to be the subject, and I'll write the x in terms of y. It will be 3 plus 2y. After you have this linear equation in the form of x as a subject, you can name this as equation 1, and the non-linear equation, you name this as equation 2. After that, I'm going to substitute the equation 1 into the equation 2. Means that for the equation 2, the x here will be replaced by 3 plus 2y. So we'll write the x as a 3 plus 2y and square plus y square equals to 26. Then now we're going to expand this. Expand this, we have a 9 plus 12y plus 4y square, and plus 4 plus of y square equals to 26. Now we collect the like terms together, and this 26 I move to the left hand side, leave the right hand side to be 0. After we have simplified, we have a one general form of a quadratic equation. Now we can start to try to factorize it. After we factorize, we have 5y plus 17 multiplied by y minus 1, yeah, equals to 0. From here, we got it y equals to negative 17 over 5, and the other one is y equals to 1. So now, after we got the value of y, we need to get the corresponding value of x. We will substitute back our y value that we got just now into the equation 1. Equation 1 given as of x equals to 3 plus 3y, 3 plus 2y. So for the y equals to negative 17 over 5, I'm going to get its corresponding value of x, substitute the value of y as a negative 17 over 5. We have a negative 19 over 5 for the x, and when y equals to 1, again, substitute the value of 1 into the y here. You got a 3 plus 2 multiplied by 1. That will be a 5. So we have two sets of solution. One is when x equals to negative 19 over 5, y equals to negative 17 over 5. Okay, the second set of solution will be x equals to 5, y equals to 1. For the second example, I'm going to solve the simultaneous equation, which these are the linear equation, and we have a three unknown, that is x, y, and z. All right, and here I'm going to use the elimination method. First, I will name the first equation as equation 1, and equation 2, and the third equation is equation 3. So how do I use this elimination method? I'm going to eliminate the z, the unknown z first. I will try to form two equations involving the x and y. Then I will solve for the x and y first. After I got the x and y, the value of x and y, then I will substitute the value of x and y that I get into the equation, either equation 1 or 2 or 3, in order to get the value of the z. So how do I eliminate? I'm going to take the equation 1 minus equation 2, because when I take the z, equation 1 minus equation 2, the z here is positive, right? Positive z minus positive z, that will be 0. So taking the equation 1 minus equation 2, all the like term must be do the same. X minus 2x, you will have negative x. 2y minus negative y, that will be 3y. All right, 2y minus negative y, you will have positive. So you get 3y, and z minus z, that is 0. 8 minus 9, that will be negative 1. Okay, so after you have this, you can multiply all the term by negative ones to make this into a positive. I will have x minus 3y equals to 1. And then you can make x as a subject. Later on, easy for you to solve for the x and y. After I have this, I will name this my equation as equation 4. The 3 has been taken here, so I'll name this as equation 4. Then I'll need to form another equation which consists of x and y only. So how can I do that? I'm going to take equation 2 plus equation 3. Add the equation 2 and the 3, you will have a z eliminated, because z plus negative z, that will be 0. So taking the equation 2 plus equation 3, you will have 5x, because 2x plus 3x, that is 5x, and negative y plus 4y, that will be 3y, and the z plus negative z, that is obtains 0. 9 plus 8, that will be 17. And I'll name this as equation 5. Since it already simplified, is no, cannot simplify further, I will just name this as equation 5. Then how can I solve for this 4 and 5? I'm going to use substitution method. That is, put the equation 4 into the equation 5. How do I put the equation 4? Means that I'm going to substitute the x over here as a 1 plus 3y, meaning that substitute the equation 4 x as a 1 plus 3y into the equation 5. So means that my equation 5 will become 5x. This x will be replaced by 1 plus 3y plus 3y equals to 17. So my equation 5 will become like this. And now I'm going to expand and simplify. So you have this, and lastly we have 18y equals to, then you have your y equals to 12 over 18. Finally, simplify this, you get a 2 over 3. So you get a y equals to 2 over 3. Now you need to get the value of x, its corresponding value of x, by substituting this y into the equation 4. So now putting this value of y into the equation 4, in order to obtain value of x, you will have cancel off the 3, you will have 3. So the first set of answer is x equals to 3, y equals to 2 over 3. So now you need to get the value of z, because you just got your x equals to 3, y equals to 2 over 3. In order to get the value of z, either you can replace into the equation 1, you can substitute those value into the equation 1 or equation 2 or equation 3. So this time I will choose equation 1. Equation 1 given as x plus 2y plus z equals to 8. So I will get my z. Z will be equals to 8 minus x minus 2y. Okay, so put your x as a 3 inside and your y as a 2 over 3. Then calculate it. Here you get 11 over 3. That is the value of z. So in conclusion, the solution of this system of linear equation is x equals to 3, y equals to 2 over 3, and z equals to 11 over 3. In my third example in this video, we still in with the system of linear equation with the 3 unknowns. I got 2 examples here, A and B. So for the example A, in this example, we still can use elimination method to eliminate the one of the variable. Okay, so for this question, I choose to eliminate the z. Okay, the unknown z, and then we try to form 2 equations involve the x and y. Then we solve for the x and y first. Then after that, substitute into either equation 1, 2, or 3 in order to get the value of z. So how do I eliminate the z? I'm taking the equation 2 minus equation 3, because what I see here is 2z. If we're taking the equation 2 minus equation 3, the 2z minus 2z will be 0. So if I take equation 2 minus equation 3, the x term, 3x minus 9x, that will be a negative 6x. And then 2y minus 6y, that will be negative 4y. 2z minus 2z, eliminated the unknown z. 6 minus 14, that will be negative 8. So simplified it, you can see that we have a common factor, negative 2. Divide all the term by negative 2, I got the 3x plus 2y equals to 4. Then we leave it first, we leave it as a equation 4. After that, in order to form another equation involve the x and y, I'm taking the equation 2 multiplied by 2. Equation 2 multiplied by 2, that will be 6x plus 4y plus 4z equals to 12. Name this as a equation 5. And taking the equation 1 minus equation 5, you will see that the z can be eliminated again. Alright, so taking the equation 1 minus equation 5, x minus 6x, that will be negative 5x. And then 4y minus 4y, just coincidentally, it can be eliminated, the y term. And then the z also eliminated. Then 7 minus 12, that will be negative 5. So you have your x equals to 1. Okay, so now to get the value of y, you can substitute the value, the x equals to 1 into the equation 4. Okay, put in the 1 inside. You have 3 multiplied by 1 plus 2y equals to 4. So here you have 4 minus 3, that is 1. Y will be equals to 1 over 2. After you have got the x equals to 1, y equals to 1 over 2, then substitute these two values into the equation 1. Or you might substitute into the equation 2 or 3, up to you. Okay, so I will choose to substitute into equation 1. I will put in my x as 1 and the y as a 1 over 2 inside, so that I can solve for the z. Simplify, I will have a 4 over 4, z equals to 1. Okay, so our full solution, that will be x equals to 1, y equals to 1 over 2, and z equals to 1. For the example B, I see there is a one equation consists of only two variables, that is y and z. So I will try to form another equation which consists of y and z. Taking the equation 2, multiply by 5, you will have a 5x over here. So 5x here and the 5x here, you can take the 2 minus 1 or equation 1 minus equation 2, then the x will be eliminated. Then you will have another equation involving the y and the z. Alright, so taking the equation 2 multiplied by 5, I got 5x. You got this, equation 2 multiplied by 5. I'll name this as equation 4. And then taking the equation 1 minus equation 4, you will have 5x minus 5x 0. 4y minus negative 35y, you will get 39y. Negative 2z plus 15z, that will be 13z. And negative 2z minus 15z, that will be 17z, yeah, negative 17z. And lastly, the constant term, you have a 2 minus 15, that will be negative 13. So here I have equation 5. From the equation 3, I will try to make the z as the subject, that I have a negative 4 minus 12y. I'll name this as equation 6. Then substitute the equation 6 into the equation 5. I have a 39y minus 17z, that is negative 4 minus 12y equals to negative 13. So now we try to solve for the y. Expand and simplify, you will have this. Finally, you got a y equals to negative 81 over 243. That is negative 1 over 3. Now we can get our z value by substituting y equals to negative 1 over 3 into the equation 6. So equation 6, so z will be equals to negative 4 multiplied by minus 12 multiplied by negative 1 over 3. We got the z equals to negative 4 plus 4, that will be 0. Alright, then now substituting the z equals to 0 and y equals to negative 1 over 3 into the equation 1 maybe, into equation 1. So this is the equation 1. I'm going to substitute the z equals to 0 and y equals to negative 1 over 3 into it to solve for the x. We got a 5x equals to 10 over 3, and divided both sides by 5, we have a 2 over 3 for the x. So we can conclude that the solution is x equals to 2 over 3, y equals to negative 1 over 3, and z equals to 0. So here is another example for the solving simultaneous equation, which now I have a question involving one non-linear equation and the other one is a linear equation. So let's look at the solution for the example A. If you have a linear equation and one non-linear equation, normally I will make my linear equation one of the unknown to be the subject. So now I make my x to be the subject. I got x equals to y minus 1. Then I'll name this as equation 1, this as equation 2. In order to solve this equation, I'm going to substitute the equation 2 into the equation 1, which means that the x over here will be replaced by the y minus 1. Alright, square plus 3. This x also will be replaced by y minus 1 multiplied by y minus 23x. X will be substituted as a 1 minus 1 and plus 8y equals to 0. So you can see that now the whole equation just involving the unknown y. We can solve for the y first. I believe that after we expand and simplify, you will have a quadratic equation which y as the unknown. So you have a y squared minus 2y plus 1 plus 3y squared minus 3y minus 23y plus 23 plus 8y equals to 0. Then we collect all the like terms and simplify it. After I have collecting all the like terms together, I have this quadratic equation and see, looking at the coefficient of all these three terms, I can see that it all can be divided by 4. So I will divide this quadratic equation by 4. I got y squared equals to y squared minus 5y plus 6 equals to 0. Then I try to factorize it. Okay, factorize it. You will have 3. 2 multiplied by 3 is 6. So negative, negative. After that, you expand back. See if you got this back or not. So after that, you get your y equals to 2 or y equals to 3. Okay, so for this equation, we got two sets of solution. We have a y equals to 2 and y equals to 3. Substitute y equals to 2 and 3 into the equation 2, that is x equals to y minus 1. Okay, you have your corresponding value of x, that is 1, yeah, for the y equals to 2. And for this y equals to 3, you have your 3 minus 1 as your x, that your x equals to 2. Our solution is when x equals to 1, y equals to 2, and another set of the solution is x equals to 2, y equals to 3. Alright. This is a second example for the solving simultaneous equation, which one equation is the nonlinear equation and this is the linear equation. For the linear equation, I always make the one of the unknown to be the subject. Again, I will let x to be my subject. So moving all the terms to the right side, I got my negative 2y minus 1 divided by 3. I'll name this as an equation 2. So to solve this equation, first we substitute the equation 2 into the equation 1 means that the x over here will be replaced by negative 2y minus 1 over 3 square minus 2. The x here also will be substituted as a negative 2y minus 1 over 3 y plus 2y square minus 20x. So when you see x, it will be replaced by the negative 2y minus 1 over 3 and plus 5y minus 4 equals to 0. Trying to simplify it and expand and simplify. When I expand all this, I got this. Now I will collect all the like terms and every term I'm going to multiply by 9 so that the coefficient of the denominator 9 and 3 okay will be eliminated. I'm going to multiply both sides by the 9. After I have simplified, I multiply all the term by 9 and simplify, collect all the like terms together. I form 34y squared plus 175y plus 25 equals to 0. You need to be careful a bit because this is a long calculation, and when you collect all the like terms together, must be very careful. Alright, then after that, we're trying to factorize it. Okay, you got this positive. So expand it back to see if you got this back. All right. Then you have your y equals to negative 5 over 34. The other y will be negative 5. Then now we need to get the corresponding value of x. This is the equation 2 that we have formed, okay, on top. Then now we are going to put the y equals to negative 5 over 34 into it in order to get the value of x. So my x now will be negative 2 multiplied by negative 5 over 34 minus 1 over 3. Here I got x equals to negative 4 over 17. So the first set of the solution will be x equals to negative 4 over 17, y equals to negative 5 over 34. This is my first set of solution. So now we substitute the y equals to negative 5 into the equation 2 to get the x value. Put in the negative 5 into it. We got x equals to 3. Now we can say that the second set of the solution is x equals to 3, y equals to negative 5. This is our another set of solution. My next example is the giving one of the equation in this quadratic and the other one is a surd. Yeah, equation involve the surd. So again, I will make this equation as y as a subject. I will write the y in terms of x, that is 3 minus x squared. I'll name this as equation 1 and this as equation 2. Again, substitute the equation 1 into equation 2. So equation 2 will become like this. So the y will be replaced by 3 minus x squared plus 2 equals to x plus 3. So now you can see that you have a 1/3 equation, which this is a 5 minus x squared equals to x plus 3. In order to solve for the equation involving the surd, we need to eliminate the surd by squaring both sides. Squaring both sides, the left hand side you will have a 5 minus x squared because we know square root of a squared that will produce a. Okay, so this is the, you try to expand x plus 3 square, you get the x square plus 6x plus 9. Alright, then after that you collect all the like terms, all the terms to the left hand side and simplify it. Here I got a quadratic equation, where this quadratic equation, all the terms can be divided by 2, so we can divide all the terms by 2. Then we try to factorize it. X 2 1 plus. Okay. Then after that, you have your x equals to negative 2, and the other solution is x equals to negative 1. For the equation involving the surd, we need to substitute back into this equation. Okay, without the square means that we're going to substitute into square root of 5 minus x squared equals to x plus 3 in order to check whether we are going to accept both of the answers or only one. Okay, so for the checking, I'm going to put x equals to -2 into this left-hand side of this equation. When x equals to -2, the left-hand side will produce square root of 5 minus 4. That will be 1. So third of 1 will be 1. And what happened to the right-hand side? When x equals to -2, the right-hand side also equals to 1. So since the left-hand side equals to right-hand side, means that the x equals to -2 is satisfying the equation. So we say that we are going to accept the x equals to -2 as our solution. Okay, then after that we have to check for x equals to -1. When x equals to -1, what happened to the left hand side? We have -1 squared, that is a 5 minus 1, that will be a 4, third of 4, that is equals to 2. And the right hand side, when you substitute the -1 in, you have your 2. Yeah, 2 as well. So it means that the left again is equals to the right hand side. So we say that x equals to -1 also will be accepted as your solution. After this, you're going to get the value of the corresponding value of when x equals to -2, the y value will be 3 minus x squared. So put in your -2 into it. You have your y equals to, this is 4, right? 3 minus 4 will be -1. This is your first solution, first set of solution. When the x equals to -1, your y will be 3 minus -1 squared. That will be 3 minus 1, that will be 2. So your final conclusion is when x equals to -2, y equals to -1, or the other solution is when x equals to -1, y equals to 2. So this is the last example. Then in my next video, I'm going to discuss the question on the quadratic equation, which we will discuss on how to use the discriminant to determine the type of root of the quadratic equation, so on and so forth. So I'll see you in my next video. Thank you for watching.